Hello, this is a review of aggregate functions. In lectures 3 and in our review in lecture 4, we talked about aggregate functions. They perform arithmetic operations on a column or a field in a table. For example, we can get an average salary, or we can get a maximum total credits, or a minimum, or a sum, or a count. And the aggregate function is what helps us do that in SQL. Here's an example. Find the average salaries of instructors in the computer science department. So following our solution strategy, we know that we are going to be looking for information from our instructors, and that's in our instructor table. And we're going to filter those instructors who are in the computer science department. Those are the goal that we're interested in. And what we want to do is find their average salary. So rather than us go through and manually calculate it, we have an aggregate function that does that for us. So the solution is fairly simple. We just say select average salary from instructor where department name equals computer science. And over here we see that we've got a representation, a schema of our instructor table, and in addition to identification information about the instructor, it has the department name the instructor's in, and it has the salary of the instructor. A group by organizes a table into groups based on a column value. It sorts on that column and sets control breaks between different values for that particular column. So, for example, we might want to say find the average salary of instructors in each department. Well, when we see words like in each or group by, that's a tip that we want to do a group by in our SQL statement. So again, we are looking at our instructor table. We note that we do have department and again salary. And we want to find the average salary, and of course we'd also want to display the department name. And we'll use the instructor table to give a department and give the average salary of instructors in that department. So we do a group by as well. So the group by, when we perform that operation, we get an intermediate, or when SQL performs that operation, we get an intermediate table that looks something like this. The table, because it's grouped by department name, the table is sorted by department name, and then control breaks are set up between the different department values. Then the next step is we perform our aggregate operation, which is we want to find their average salary by department. And then the result is the table on the right, where we see we have the average salary by department. So although we're giving the average salary by department, we got that information from the instructor table, because that's where we have department name and average salary. Sometimes we need to do a select on an aggregated value done by an aggregated function. So in other words, we don't want to find all of the departments here in our list. We only want to find certain ones. So we want to filter on this final result table we see on the right, and we use something called the halving clause to do that. And the halving clause is similar in its function to the where clause. The where clause acts on individual values in a table. The halving clause works on aggregated values in a group by result. So an example of a problem we might address with this kind of query is find the names and average salaries of all departments whose average salary is greater than $42,000. And the answer is a query like this. Select department name and average salary, because that's what we want, the names and average salaries of all departments. So we want the department name and the average salary, and it's for instructors, because the instructor is where we have the salary information. If we look at our schema overall, for department, there is no salary field. Departments don't have salaries. Students don't have salaries that we're interested in. Courses don't have salaries. The sections don't have salaries. It's instructors who have salaries. So even though the question is asking for the average salaries of all departments, what we're looking for is the average salary of instructors from all departments. Obviously, departments don't have salaries, they have budgets. So we do our select department name and average salary from instructor. We group by department name because we want to find the average salary by department. But we not only want to display the average salaries by department, we want to further restrict that and say only those departments who have a salary, an average salary greater than $42,000. So we add the having clause in to accomplish that. So we group by department name, and then we do our average salary. Then at the end, we do a filter on that and say, well, we only want to display the results that have an average salary greater than $42,000. The predicates in the having clause, in other words, the conditions, are applied after the formation of groups, whereas predicates in the where clause are applied before forming groups. And again, we can look at our schema and we see that the only table that has salary is instructor, and that makes sense intuitively. Instructors do have salaries. That's one of the items of interest we would have for our instructor table. Instructors are also part of a department. So because of that, we can find out the average salary by department by looking at the instructor table. Thank you. This is a quick review again of aggregate functions.